Hi everyone, I'm currently building an energy storage system based on a Raspberry Pi. The too long didn't read version of this. Why would you need one? Because you can. Does it make energetically any sense? It depends. Longer answer later. Does it make financial sense? Well, no. Not unless your cost for electricity to buy is significantly different from purchasing versus selling it back to the grid using the solar energy, feeding it back in. If you have something like 10 to 15 cents of difference between buying and selling, then yes, you could financially make it work. Possibly. It depends. Okay, so does it make energetically any sense? Well, if you use lithium batteries, you mean like these ones, 18615. This one's completely rubbish because it's 0 volts. That's not any good. So what I'm using now is a standard RC lithium polymer battery because testing, yes. It's what I had laying around. It's just 3 cells, but it'll do, at least for this purpose. Testing. The lithium batteries are generally somewhere along 95% efficient. If you have a charger, which could be basically a power supply, you're looking at something between 90 for a good one and 95 cents for a really good one. Percent efficient. Yeah. So, if you have a grid tie inverter, the Chinese ones, you're lucky if you get 90%. It's probably more like 85. And if you buy a brand one, you get something like 95%, which is pretty good. So if you put 0.90 to the power of 3, you get something like 80% efficient overall. I mean, going from AC to DC and from DC back to AC, feeding it back in while your house is consuming it. Yeah, you could make that work, but you need to take into account that you need 20% more energy than you had before if you could just feed it back in for the same price you had bought it from. Yeah, that's what I meant with it could be financially worth it, but only if your tariffs are really far apart. Anyhow, so what you have here is a Raspberry Pi. You have a Pi face on top, because that's what I already had. And if you look a bit closer, you see an analog to digital converter on the bottom. The middle one, with lots of rows of pins, is the PWM servo board. Those are from AB Electronics. They don't make them for the original Raspberry Pi. They have the new ones which fit the Raspberry Pi Plus and 2 and 3. So you have 2 relay boards. This is AC, and then you have the DC on the other hand. A small voltage divider. Well, this one is crap. I need to build a new one. I'll explain later, but basically the ADC board already has a voltage divider, so you just need a pretty decent resistor in front of it and you're done. Very small voltmeter. Well, it says 11.3, but don't take it for granted. It's pretty rubbish. It doesn't take into account pulse width modulation very well, or frequencies, or it's accurate in general, because it says 11.8 when you're actually seeing 12. And then you have one on the other hand, which is a bit more optimistic and a bit more accurate. Then we have a large PWM board. This is a Chinese PWM controller which you drive using the Raspberry Pi. You need an opto isolator because I tried, and connecting grounds and all that thing, that's not really how it's supposed to work. You need an opto isolator, cost you €5, pounds, dollars, something like that, and you won't have that issue. This is a 40 amp model, but it's Chinese, so it's probably more like 10, which is what I'm targeting. So there. What do we have more? A 3D printed fuse holder, an ACS712 current resistor, but I don't have any analog inputs anymore, so I can't connect that right now. Then you have 3 AC outlets. The bottom one is permanent, 230. You have 3 AC outlets. The bottom one is 230 AC. The second one is for controlling the grid tie inverter, which I don't have yet, at least not a spare one. And the top one is for charging the battery, which is also controlled by the AC board. So the left part of the whole board is basically AC and the right part is DC, and lots of wires in the middle. Well, so how does that work? Well, I've written a application in PHP for the Raspberry. So what you see here is you have the utility meter on the top left. It gets the meter readings using a Arduino Nano with an Ethernet shield. It reads the P1 serial port on the meter, sends it over the network to the Raspberry Pi, and I process it here in PHP. So as you can see, it's currently feeding back in 1120 watts, which is excellent. That's about what I hoped for. What we further have, we have a T connection, and we are, well, it's simulating the 320 watts charging, but it's not, because this power supply is 12 volts and 1.5 amps. So yeah, it's more like 18. But anyhow, you can configure that all in the scripts and files, etc., etc. It says it's currently running, the timer is updating, which is good. As you can see, the ADC to converter board, it's not very accurate, is it? So the first cell, 3.61, yeah, that's a lie, that's 3.7. And then you have the second and the third cell, which are also lying, because they're about 700ths of a volt incorrect. Because the 391 is more like 386 and the 381 is more like 373. Yeah. It's not entirely accurate. I need to do the voltage divider again, but with better resistors, which are more accurate, and that should read far better. Anyhow, it does have some controls for hysteresis now, because the relays kept flip-flopping, because yeah, you stop charging and the power drops. Oh, I can charge again. Yeah, no, that's not really what I meant. The code is in GitHub. You can find it under smos/bav. Back and forth. At least that's the ID. Well, yeah, no, it's not finished yet. But at least I have some rudimentary instructions for building this. The screenshot I have there is older, but well, it'll do. If you want a new screenshot, build it yourself. How about that? So yeah, this is basically working, and if you, as soon as you see the consumption go, it'll go the other way. You can configure it in various ways, depending on the power, if you have a PWM at all, because if you set the minimal PWM level to 100, it'll basically just drive the relay board. So if you likely want to do this on a very, very cheap basis with just a basic charger and a basic discharger, or a grid tie inverter in my case, you can skip the entire PWM step and it'll just work. Yay! Anyhow, the battery, it should have been 8S, but it's not built yet, but that'll get there. At least you have basically an idea of what it's supposed to do. And if I just power on the oven for a bit. There we go. Let's see. It should see consumption. There you go. And it's decided things need to change. There are some timers involved. You have basic timers for cutting off the AC relays. You have pretty much no timer for the DC discoupling, because that's not what you want. That needs to you never want to have the charger feeding the inverter, if you get what I mean. But that's the basic idea. So what you now have now is you see a different relay on the left and right, and what you can also see is that relay 1, which is the bottom one for the AC, is still on because it has a countdown timer and should fall off somewhere after 60 seconds. I have something similar for the grid tie inverter, but set it to 300 seconds because yeah, those need a startup time and you'll want to leave it on for a bit before it falls off. It still says 12 volts because the AC is still on, which is alright. And the bottom one isn't doing anything right now because it's rubbish. It's supposed to feed in, but it isn't. It's not done yet. Anyhow, that's basically the idea. And if I then switch the oven off again, there you go. It should disable DC for the one and go back to the DC for the others. There you go. Ta-da! Ta-da! The software uses 5 run levels. You have 0, which is idle, you have 1, which is standby for charging, and you have -1 for standby inverting. And then you have 2 and -2 for actually charging and inverting. It should always cross all the run levels before doing the one thing, so there's always a minimum delay of 3 seconds between all things it's doing. That seemed like the safe approach. Anyhow, that's how far as I've got. I really need to make this a bit better because it needs an opto isolator between the PWM board and the actual PWM controller because connecting grounds is bad, okay? Yeah. At least progress has been made. Bye.